welcome everybody. I hope you can hear me all around on YouTube as well. Thank you very much for this generous introduction. And today I'll be talking about, as you can see, a big project, not a big project, but a project involving a lot of colleagues. It's an interdisciplinary team. My co-researchers are Hyeonjeong, Jeong, Shunshui Matsuura, Motoaki Sugiura, and Haini Chui from Tohoku University in Japan, who are neurolinguists, neuroscientists, and also Shungo Suzuki from Waseda University, and Kazuya Saito, who is in the room, and probably all of you know. So it's a team of neuroscientists and behavior researchers, and maybe I should say the beginning, I'm more of a second language acquisition researcher, as you've heard. I don't have the neuroscience background that some of my colleagues have. So let me start with a brief background to this study. I'll be talking about the neurocorrelates of mid and end close pauses in R2 speech. So what does speech production involve? Sorry. Just some technical issues.
This could always happen.
Okay.
Yeah. Apologies.
No worries at all. So yeah, let me start with an introduction again. So the study is conceptualizing speech production research. So let me go through some of the main stages in second language speech production. When we speak in a second language, first we need to conceptualize our speech. We need to think about what we are planning to say. The next, here. And then what we do once we have a plan, what we would like to say, then we formulate these processes through lexical, grammatical encoding, morphological encoding, and phonetic encoding processes. And once we have this linguistic form, we translate this into a phonetic form through articulation processes. And the last stage when it comes to speech production is monitoring, which happens interactively. All of these stages happen interactively, and monitoring happens at all stages. We constantly check what we would like to say is aligned with our intended message. But sometimes conceptualization and formulation processes are difficult, especially when it comes to second language speech, and these might result in disfluencies. When it comes to disfluencies in second language speech production or first language speech production, we can make a distinction among three types of fluency. Speed fluency, the rate of which has to do with the rate of delivery. Repair fluency, which has to do with repetitions and self-corrections in one's speech. And breakdown fluency, which captures pausing behaviors. Among these various facets of fluency, breakdown fluency seems to be particularly important because research has shown that perceived fluency is more related to breakdown fluency than speed and repair fluency. Perceived fluency meaning how raters perceive how fluent somebody's speech is. In a recent meta-analysis by Suzuki et al., it has also been found that mid-close pauses are more strongly related to perceived fluency ratings. From first language acquisition research, we know, and at least it has been assumed, that pausing at different locations is going to be associated with different speech production processes. End close pauses are assumed to indicate engagement in conceptualization. Remember, this has to do with what one wants to say. On the other hand, mid-close pauses might signal breakdowns in lexical and syntactic encoding processes. And there is also empirical evidence suggesting that this might be the case. L1 speakers, when you speak in your first language, you're more likely to pause between than within clauses. So we're not disrupted with linguistic encoding processes, but we might get disrupted if we need to think about what we would like to say. It has also been found that mid-close pausing in first language speech typically occurs before open class words, if it does happen, when we try to say less frequent words, probably that we use less often than more frequency words. Compared to first language speech, what we find in second language speech, that L2 speakers, not surprisingly, tend to pause more often mid-close than L1 speakers, and less proficient L2 users pause more often mid-close. So there is also the proficiency element. Again, the less proficient we are, the more likely we might struggle with linguistic encoding processes, which might be reflected in mid-close pausing. This is what I've just said. In light of this, second language acquisition researchers assume that mid-close pauses might be linked to second language difficulties in constructing a syntactic frame by forming lexical links, basically linguistic encoding processes. But when it comes to end-close pauses, we do find that L1 and L2 speakers don't differ as much. Again, when it comes to deciding what we want to say, is not likely to differ across L1 and L2 speakers. And this is probably because end-close pausing, again, might relate to conceptualization processes. All of these insights so far have been derived from psycholinguistic studies, and there is no direct evidence about the neural processes underlying second language speech. So the aim of our study was to examine the neural processes of silent pausing, how location of pausing, whether second language speakers, in our case, pause mid-close or end-close, may relate to differential neural processes during spontaneous speech production. So our specific research question was as follows: to what extent does the location of silent pauses, whether it happen mid-close or end-close, relate to neural processes during second language speech productions? And in light of the literature review, you won't be surprised that we assume that mid-close pauses would be linked to activation in language-related brain areas. On the other hand, end-close pauses would be linked to activation in conceptualization-related brain areas. Our participants were 26 Japanese learners of L2 English. We had to exclude 2 participants due to issues with the recording. They were all university students. There were 12 female, 14 male students. The mean age was around 20. And they all did the Oxford listening test. And it seemed like that the majority were at the CFR B2 level. And we also had a few C1 participants. This meant that they were able to speak and produce speech during the task that we asked them to do. These are the 8 tasks they completed. They were all monologic speaking performances. They were asked to talk about disaster-related topics. At a conference, somebody asked me why disaster-related topics, because this was the grant call we tried to go for. So this is the reason why we went for these. For example, they had to talk about or react in a situation when there was an earthquake, vaccination, flooding, and so on. Here's an example for one of the tasks we asked them to engage in. Imagine you're a firefighter, you're called to a fire in a tall building, you arrive with a helicopter, but there are 8 people on the roof and you can't take everybody. Those of you a language teacher, the typical desert island scenario, but now on the top of a building. And then we had people with different characteristics and people had to make a choice which 5 people they would take. They had 1 minute planning time, and then they had 2 minutes for the actual speech performance. Some of these, or half of these tasks were carried out in L2 English, and the other half in L1 Japanese. But now in this presentation, I'm only talking about the L2 speaking performances. Task type and language were counterbalanced across the participants and the sessions. They were doing all of this in an FMRI scanner. And altogether, we had 30 minutes and 19 seconds of speech performances collected. While participants were talking, we need to use a noise reduction microphone. I tried this myself. The FMRI machine is very loud, and actually it was very difficult to transcribe the speech performances. And I don't think we'll be able to do human ratings or any of that sort. You can see the difference there. If you look at the figure, what you would hear when you have the no noise reduction microphone and when you have the reduction microphone. So this was an important element of the experiment. The scans were repeated every 2 seconds, and in those 2 seconds, 53 slices of the brain were carried out, and that resulted in 14 and 17 volumes per second. Then what happened once we had this data, we transcribed the task performances. We had 4 tasks, remember, and we had 24 participants, so it led to 98 task performances. We did the transcriptions through Pratt. Again, this was a difficult procedure just because of the very loud recordings. And then we used Pratt software as well to analyze the speech performances. This is the type of output you would get there. And we had 3 tiers in our Pratt analysis. First, the task type, and then we also had the transcription. You can see the participant was saying, maybe you might not see, if I were in the sinking boat, I will choose knife and light, knife lighter, something along these lines. And then in the last year, we coded these speech performances. We coded for pause type, whether participants made silent or field pauses. There were relatively few field pauses in our data set, so we only looked at silent pauses in our analysis. And we also coded whether these poses occurred mid-close or end-close, and our pause threshold was 250 milliseconds. This is the typical pause threshold adopted in speech production studies. Here's an example for an end-close silent pause between, if I were in the sinking boat, pause, I will choose. This is between two clauses. And here's an example for a mid-close silent pause. I will choose knife like, knife lighter. Right, in terms of the fMRI analysis, we conducted a within participant analysis. We did a vocal by vocal multiple regression. I should say my colleagues at Tohoku University did this, so don't ask me detailed questions about the statistical analysis. And then we did contrast images between mid-close and end-close performances. And then a one sample t-test was used using statistical parametric mapping software. This is the typical software which is used in fMRI data analysis. Those of you who are familiar with fMRI research, you might be wondering how it was possible to do this, because the sampling rate is only 2 seconds, right? So how can you look at pause thresholds at 250 milliseconds? We used a so-called jittered rapid presentation event-related design, which means that the interstimulus intervals were jittered. So in a way, when the onset of a pause started, it's not always at the same 2-second interval. So in a way, if you do this, and it's a random distribution when it comes to pauses, you can actually look at shorter time intervals as well. So it's possible to do this through fMRI imaging. As I just mentioned, this sort of jittering design that you would do artificially in an experiment, we didn't need to do it artificially, because when it comes to pauses, they happen in a random order, right? It's not every 2 seconds you would have a pause, but it could vary depending on the speech production process. So what did we find? Let me just remind you of the research question. To what extent does the location of silent pauses, whether they occur mid-close or end-close, relate to neural processes during speech production? Again, mid-close pauses, we assume that would be related to language-related areas, and end-close pauses would be linked to activation in conceptualization-related brain areas. Altogether in our data set, we identified 4,983 silent pauses. 70% of these, around 70% of these occurred mid-close and 30% end-close. And the mean was 208. Mid-close, the mean was 146 and 62 per participant. So what did we find in the fMRI analysis? We found a significant effect for pause locations. And we did indeed find, when it comes to mid-close pauses, they were associated with greater activation in areas which are sensitive to linguistic encoding, linguistic difficulty. These are the left inferior frontal gyrus, in particular the opercular and triangular areas. And these areas in previous neuroscience research have been associated with syntactic processing and retrieval of words. And we also found that there were greater activation in the basal ganglia when it comes to mid-close pauses. Again, this is an area that in previous research was associated with syntactic processing. So our first hypothesis seems to have been confirmed. What about end-close pauses? What we found that end-close pauses were associated with greater activation in so-called areas which are sensitive to theory of mind activities. This is the precuneus area, which is part of the theory of mind network. We did think that actually goes aligned with our hypothesis that conceptualization-related areas might be more linked to end-of-close pauses, because theory of mind activities are related to conceptualization. I discuss this in more detail later. So first, when it comes to mid-close pauses, again, our hypothesis was confirmed. We did find that mid-close pausing related to activation in language-related areas. So again, our neuroscience data really nicely aligned with the psycholinguistic data we found in previous SLA research. When it comes to enclosed poses, again, these were related to theory of mind activities, and we assume that it's actually fine, and it goes well with our assumption, because theory of mind activities can relate to conceptualization. What is the theory? What do we mean by theory of mind activities? The theory of mind system underlies humans' ability to understand others' beliefs, desires, and intentions. So when we speak and when we communicate, when we talk to somebody, we always need to rely of this particular system. It's an essential part of social interaction and verbal communication. So we thought this is actually quite logical if you think about the type of tasks we had, because we asked participants to imagine that they in somebody's place, they have to decide who to take from that rooftop in the task that I show you. So they had to act, they had to use their theory of mind framework. They needed to infer what someone would do in that situation. So it probably had to do when they were planning what to say and how to act in that situation. What do we know about the theory of mind network in previous neuroscience research? We do know that it plays a key role in any sort of language-based communication. This has been shown previously when it comes to written comprehension. This framework, this system seems to be involved when it comes to reasoning about intentions and mental states. When it comes to written comprehension, there are a few studies which show that. And our collaborator, Hyeonjeong, also found in her own research that theory of mind network is involved in communication or speech production, I should say, but that happens for communication and not just using speech production without a communicative intent. So theory of mind seems to be involved in speaking activities as well. In her study, however, this was a really controlled experiment. Participant could only say a noun or a sentence, like somebody is playing the piano or talking to somebody, but just one sentence and not longer. And the innovation of our study was that it was relatively spontaneous speech production, as spontaneous as it gets in a fMRI scanner. But participants could produce, and they did produce, longer stretches of speech. So what are the implications of this research, and what did we find? First of all, it was interesting for us to see that actually our assumptions that were derived from psycholinguistic research were nicely triangulated with the neuroscience data. Indeed, mid-close and end-close poses were associated with the processes, cognitive processes that we assume they would be. But we also found, which was interesting, that the neuroimaging data actually gave us additional insights that we might not have seen just based on behavioral data. We might have assumed that the theory of mind network is involved, but this is not something we would have figured out just based on the psycholinguistic data we had. So in a way, the triangulation of these two data sources led to new insights. We think, or we hope, that cognitive neuroscience researchers will also be interested in this, because we also provide new information about theory of mind effects. Because as I mentioned earlier, previous research in this area has focused on written narrative comprehension, but not. This is one of the first studies to look at spontaneous speech production. So the theory of mind network is involved in spontaneous speech production as well. Right. So I've just said this, that from a methodological perspective, we also think this is interesting because we managed to provide and combine these two data sources. But of course, the study has a number of limitations. If you've ever been in an fMRI machines, it's definitely not an ecologically valid speech performance, but it's doable. It can be done. One limitation of the study, among many, is that we triangulated two data sources, but it would have been really interesting to ask participants to tell us what they were thinking during those poses through a stimulated recall procedure. So hopefully in the future, we will also be able to do that and have these three data sources. So we also have some insight to participants' conscious thought processes. What are we doing next? As I mentioned, we have the L1 data, so it will be really interesting to see how the L2 and L1 data compare, especially in this type of experiments when you do something new and you don't have a baseline. Having a baseline is really important, so we're in the process of analyzing that data set. As you might have guessed, those of you doing task-based research, we had the task complexity manipulation as well. I haven't talked about that, but we also look at whether that choice between who to take in this case is more simple or more complex, whether it does make a difference in terms of neurocognitive processes. And we would also like to relate the process data to linguistic measures, and we have the data to do that. So hopefully that will happen in the future as well. So thank you very much for your attention.